Hello AQR students. We are looking at Student Activity Sheet 4, Road to $1 million. So we're kind of flipping what we did in Student Activity Sheet 3 here. So you can see, just reading through these first two paragraphs. In Student Activity Sheet 3, you analyze the future value of investment over time. You began with $2,600 invested in a savings account for 30 years. After 30 years, your initial investment would be worth $9,062.70. In this activity, SAS4, you will look at the same investment in a different way. The question relates to the time value of money. What is that $9,062.70 future value worth at various times in the 30-year investment? So the following table lists the principal required to obtain the same future value of $9,062.70 for various investment lengths. So in the table, the 30-year investment is the one you have already explored. The other values in the table show how much principal you would need to invest and the length of time of the investment for the same yield. This can be thought of as the present value of the investment. So, for example, if we were going to keep this investment for 15 years instead of 30 years, but we wanted to still end up with that $9,062.70, well, in 15 years ago, we would have needed to invest this amount of money so that now we would have that $9,062. If we go back the whole 30 years, we only need that $2,600 though. Okay? So it says create a scatter plot. Number one says create a scatter plot. You're going to draw that out. Number two is going to ask you to find the regression equation here. Calculate the regression equation for the given data and graph the regression equation on the scatter plot. Explain why, blah, blah, blah. All right, so again, we're going to use Desmos here. So I've got my little computer here, and so go to desmos.com. We're going to start graphing. Once we get the graph up here, there we go. We're going to hit plus, and you're going to go to the third line down, which is table, and then you're going to put in your table. So again, just like last time, I'm going to put in different numbers and kind of show you the process, and I'll let you do this part on your own. Okay? So, okay, there we go. All right. So I already put these numbers in. I still have 0 through 30 just like y'all do. 0, 5, 10, 15, 20, 25, 30. But I have different numbers in my Y values. Okay? You're going to use the numbers on your table. You might just watch this for right now. And these are the same numbers I had for my problem I did last time for y'all. To set your window, you're going to need, something smaller, for your, I'm going to click the little wrench up here. And so for the x-axis, I want something smaller than 0 and something bigger than 30. So I went from -2 to 33. Just a little bit smaller than 0, a little bit bigger than 30. And then for my y-axis, I wanted something smaller than 4,000 and bigger than 12,000. All right. So I put 3,500 to 13,000 here. 3,500 to 13,000. So on yours, you might put like 2,000 to 10,000 or something like that. Okay? But once you got that all set, you should see your scatter plot. So here's my scatter plot. I can see that it has a little bit of a curve to it, not a whole lot. And once again, we want to find this regression equation that fits. So I'm going to come up here to my plus sign, click on that, and then I'm going to go to this first thing that says expression here, and click on that. And I'm going to say y, and then I'm going to use the underscore, which is shift right above the dash, underscore, and I'm going to put a 1 in there. And that means it's going to apply to y1 right here. I'm going to press my right arrow to get it even again. And now I might get the tilde, which is, I guess you can't see this on my keyboard, but the tilde is just to the left of the 1. So shift, tilde, get this out of the way. And I'm going to put mx plus b here, but my x has to be x1. So mx, and then I'm going to use my underscore 1. Press the right arrow to get out of the underscore, plus b. And I get an equation here, and it's pretty good. It gives me this line. It's going very close to all the dots. It only hits like one of the dots, well, 2 of the dots it looks like. It just grazes 2 of the dots, misses the others, but it's pretty close to them. You can see my R value is pretty close to a -1. It's about -0.99. And that's really good. That's a really good regression equation for this. Let's try the exponential because it has a little curve to it. I'm still thinking exponential might be better. So I'm going to backspace back to I'm going to leave the y sub 1 tilde. And I'm going to put a times b. And now I'm going to use the caret, which is the shift on the 6. And I'm going to put x underscore 1 there. So a times b to the x sub 1. And now this time you can see my r squared value is exactly 1. Okay? So this is this, and you can see that the line this curve that it's drawing goes exactly through right every single point. So this really is an exponential function here. It is an exponential function. Okay? So I'm going to move this out of the way for just a minute. Go back to my paper here. All right, so my equation, my regression equation is, where did I write it down? y equals $12,069.90 times 0.9639. This is dollars, so round that to 2 decimals. And then this b value, we're going to round that to 4 decimals, 0.9639 to the x power. And the reason it says if we did graph it, it went right through our scatter plot, explain why this makes sense in the problem situation. Well, it's because it's compound interest. We're talking about compound interest, and that's when we're going to have exponential functions. Okay? All right, let's look at number 3. Again, you're going to get different numbers here than I got, so be sure to do that on your own. And I'll ask you to input that when we get to the end of this lesson and you're doing your assessment. You're going to be inputting your equation. Josephine is 20 years old and wants to save $1 million for retirement in 50 years. Assume she invests in a savings account that earns at least the current rate of inflation. Determine how much Josephine must save today to reach her retirement goal. So we want to know the present value. We know in the future she wants to have $1 million, and that's going to be 50 years from now. She's going to savings account that earns at least the current rate of inflation. Determine how much she must save right now. Okay, so it doesn't tell us how much to compound or anything like that. So let's keep it pretty simple. Let's say the current inflation, and I just looked it up. We'll get a new one. The end of this week apparently we'll have a new inflation rate for bringing March up to date. But it was through February, our inflation rate for the last 12 months is 2.3%. So we want a savings account that earns more than that. So let's say our savings account is paying, let's just keep it real even, let's make it 3%. All right? Now our equation says future value equals present value times 1 plus I over n to the nt power. And we want to solve this for PV. We want to know what PV is. Okay? How much she can save right now so that she'll have $1 million in the future. So what I can do here is I can simply, to get the PV by itself, I'm going to divide by this right here. I'm going to divide by 1 plus I over n to the nt power. And I have to do whatever I do on the left, I have to do the same thing on the right. And then this is all going to cancel out. And I'm going to flip it around, but PV is going to equal, the present value equals the future value divided by 1 plus I over n to the nt power. So I'm going to let you put in the numbers here. Future value, we know that's going to be $1 million. I said 3%. If you want to make it something different from 3%, that's fine. I'm going to let you decide how often you want to compound. Do you want to compound quarterly? Do you want to compound monthly? Okay? I'll leave that up to you. And let's see what you get for the present value there of that $1 million. All right? Okay. Let's look at number 4 now. Suppose Josephine does not want to begin saving for her retirement immediately. Fill in the following table to show the amount of money that Josephine must invest to retire 50 years from now with $1 million based on the number of years that she waits to start saving. Okay? Well, if she waits 50 years before she starts saving, she's going to need $1 million. If she wants $1 million, then if she waits 50 years, she's going to need $1 million. If she doesn't wait, this answer on 0 should be whatever you got on number 3. That should be your answer from number 3. And then it should progress from that number. It'll keep getting bigger until it gets up to $1 million. So if she waits 10 years, that means she'll have 40 years of compounding. And so you're going to use 40 for T in that same equation from number 3. If she waits 20 years to start saving, that means she'll have 30 years of compounding. Put in 30. If she waits 30 years to save, she'll have 20 years of compounding. Put in 20. If she waits 40 years to save, put in 10. 10 years of compounding, and each of those will give you different values here. Okay? So do that, and then answer number 5, and that will be it for day 1. That is everything that we want to do for day 1. Okay? Good luck with that.